Yes, it's the limit, and these are very important concepts. Applications of these concepts are there in physics, in chemistry also. All these concepts are called under calculus. I think you might have the chapter with the title pre-calculus. Once we told it about it, pre-calculus. Right. As you have Desmos, try to draw this function in Desmos.
Yes, sir.
Will be surprised. Function f of x is equal x square minus 4 by x minus 2. Let's write.
Yes.
X square minus 4 how to reduce this?
So,
Given
so reduce in the sense look closer.
minimize.
Oh,
Given.
so control. Okay, never mind. That's right.
In the graph.
So in a graph, we can just put this cursor in the graph, and then
Yeah.
with two fingers, we can just make it closest. So you see the plus or minus in the right side, sir, of the graph, the tools.
Yeah. This side, what happened?
The right side plus or minus, sir.
Yeah, it's not maintaining that. If for x is equal to, it
Yes,
shows 4. Got it?
sir. Yes, sir.
For x is equal to, it says y is equal to 4, but it's not correct.
It's not correct. So
But
did we
see what happens when we put x is equal to in this equation?
Oh, it will be 0, sir. 1 second. It is not correct, sir.
Yeah, it gets 0 by 0 form.
Yes, sir, but
So it should be a gap. That means a hole there.
oh, asymptote. Yes, sir.
Yeah, at x is equal to, there must be a hole. Because at x is equal to, this function is not defined. Okay, let's try another.
Oh, it's not defined, yes.
1 over x minus 1. Yeah, it's good. It's correct only. For this graph, it is correct. You know why? For for 2,
Yes, sir, it's having the asymptote.
yeah, for 1, for x equal 1, what it says, what it shows,
X equals 1, it doesn't.
there is no y value for x equal to 1.
Yes,
Got
sir,
it?
there's a.
Instead
Yes.
of that, it draws something, some line, but there is no y value for x equal to 1.
Yes.
Yeah, it's correct only. Yeah, it is mistake. See, there should not be y value for x
Yes.
equal to 1,
Yes, sir.
but it ignores. The software ignores that case.
One.
Okay, let's try it.
I think Mathway is gonna give us a good one. So 1 second, let me check.
No problem, we can write.
X square minus 1.
Suppose this is the correct graph of we are drawing the graph for f of x is equal to x square minus 4 by x minus 2. It's very interesting.
Yes. So every software like doesn't.
Yeah, yeah. I will tell you the reason why it draws like this. There is a reason.
Yes, it ignores the fact that it's a whole.
Yeah, there is a reason for that software ignores that value. There is a valid reason. 2, 3, 1, 2, 3. You may discuss the same with your professors also. Actually, at x is equal to, this function has no y value. This function has no value.
Yes.
Even though it draws, that is called discontinuous functions. Discontinuous. This function is discontinuous at x is equal to, actually.
Yes.
Minus 2. Tell what if x is equal to minus 2? What is the value of f of x when x is equal to minus 2? What happens when we take x is equal to minus 2?
0, sir.
Very good. 0. No, no, no. Yeah, numerator is 0. Very good. 0 by negative 4. Yes, you are right. What is x is equal to minus 3?
For minus 3, negative 1, sir.
Minus 3 means 9. 9 minus
9.
5. 5 by
Oh, in that way, yes, sir.
right? 5 by 5 by
5 by 1.
negative 5.
Negative 3, negative 2, negative 5, yes, sir. 5 by negative 5, negative 1.
Negative 1, right? See, for x is equal to minus 3, y is equal to negative 1. This is the point. For x is equal to negative 2,
0, sir.
0. Very good. For x is equal to negative 1,
1, sir.
very good. 1 minus 4 minus 3. Minus 3 by minus 3, 1. Very good. For x is equal to 0,
2, sir.
for x is equal to 1,
3, sir.
right?
Yes.
This is the graph. For x is equal to
4. Wait, sorry. Yeah, 4, sir.
for x is equal to
4, sir.
2.
I mean, it should not show anything, but then the graph says.
Actually, for x is equal to, there is no value. Okay. That means we are finding the value of f of 2. 2 square minus 4 by 2 minus 2. What is 2 square minus 4?
0, sir.
0. 0 over 0.
0, sir.
No.
Oh, and
0 over 0 is not square, not 1. It is very highly complicated concept. That is
I said
form.
yes, sir. 0 by 0 is 0, but then it's
value. It is
yes,
called
sir.
indeterminate form.
Yes, sir.
So we should not take actually this function. This function doesn't take 2 x equal to.
Yes.
So 2 is not in its domain.
Yes.
So what should be done? For C, it is possible for x is equal to 1.9 also.
Yes, sir.
When we take x is equal to 1.9, f of 1.9.
1.9 minus 4.
Minus 4 by
3.6 minus 4. Negative.
Negative
0.39.
Very good. By negative 0.1.
2.1.
That is equal to 3.9. Negative 3.9 by, sorry, negative 0.39 by negative 0.1. That is equal to 3.9. Got it?
Yes, sir.
So for 1.9, it is 3.9. For 1.9, it is 3.9.
Yes, sir.
It's possible. It is possible for even for 1.9. It's possible even for 1.99. 1.999, 1.999, 1.999, but not possible for 2.
Yes.
Now, what about f of 2.1? (4.41) minus 4 by 2.1 minus 2. 4.41 minus 4 means how much?
0.41.
0.41 by 0.1.
Yes.
Value 4.1. So for x equal 2.1, it is possible. Even for x equal 2.1, it is possible. 2.1 for it is 4.1. Got it? So it goes like that. From that then onwards, if it is possible for every value. So what is to be understood here? It's not possible for it's not possible for 2. For x equal to, it is not possible. It is possible for x is equal to 1.9. It is possible for 2.1. Possible for 1.99, 1.999, 1.999. Everything is possible, but except 2. For 2, it is not possible. So it is not correct. It is not correct to continue this. Very clearly, it is a whole. So this function has whole at
2, sir.
2. Yeah, it is very clear. Mathematicians are interested to know what is the value of 2. What is the value of this function at x equal to? Very clearly, they understood that it is not possible. It is indeterminate form. At x equal to, it is not possible to find its value. Then scientists got interest in, of course, it's not possible for x is equal to. At x is equal to, this function has f of x has no value. It's very clear. So mathematicians' interest is especially Newton and Leibniz. Newton and Leibniz were given credit to develop this subject, this concept. Very clearly, at x equal to, it is not possible. And surprisingly, it is possible for every value nearby 2. That means less than 2 is possible, greater than 2 is possible for whatever value, for whatever small value. That means 2.1, it is possible for 2.1. You know, it is also possible for is also possible for 1.999. You may write as many lines as you wish, as you can. Even then, even for this value, it is possible. Maybe its value is 3.999999, something like that.
Yes.
It is also possible for 2.00000000000. It's also possible for this value also. How interesting is this? This function is defined for any value nearby 2.
Yes, sir.
It is defined for all values nearby 2, but it is not defined for 2. Then the curiosity develops. Of course, it is not defined for x equal to. Then What? See, the new symbol is introduced. That symbol is called, it's like arrow mark. This is called tensor. It is read as tensor. X tends to 2. X tends to 2 means X is approaching 2. That means X approaches 2.
Yes.
Its meaning is X approaches 2. It's read as X tends to 2. Meaning is X approaches 2, right? Then scientists thought about this concept. It is written as limit X tends to 2, X square minus 4 by X minus 2.
Yes.
Yeah, they are finding its movement.
Yes, sir.
Yes, its movement. When X is approaching 2, that means we got, for the values of X approaching 2, we got the values like this: 3.9, 3.999, 3.999, 3.9, like that. So X value is trying to reach 2. X is trying to reach 2. Then f of X is trying to, can you guess what is that value?
Reach 4.
Yes. If X tries to, if X is trying to reach 2, then f of X is trying to reach 4. See here, for f of X, f of 2.1. Okay. X, this is nearby 2 and this is nearby 4. This is nearby 2. This is nearby 4. So if X is nearby 2, then this function is nearby 4. That's the concept of limit. It's very interesting. It's up. Without this concept, without this beginning, there will be much physics. There will not be much physics concepts. Everything, even kinematics and every concept uses this concept. From this only derivatives and integrations are developed.
Yes.
So let us write this. There is a mistake. There is a fault. Practically, we understood that its value is 4. Right? Now, let us take an interesting calculation. Take this calculation. Let A is equal to B.
Yes.
Can we take like this? Consider A is equal to B. Multiply both sides by A. Tell that step. Multiply both sides by A.
A square equals BA.
Very good. Subtract B square on both sides.
A square minus B equal AB minus B square.
Use A square minus B square formula. You know, A square
Yes.
minus B square formula is
A square minus B square. A times B.
A
A plus
B
times A minus B.
B is common factor. Take B. Common. Take
A minus B.
A minus.
B.
What is common factor here in both sides?
A minus B. Sir.
A minus B. Divide both sides by A minus B.
A plus B equals B.
Yeah, before that, write this stuff. A plus B times A minus B by A minus B by A minus B. Is equal B times A minus B whole by A minus B. What happens now? Any cancellation?
A minus B and A minus B. Sir.
Are you sure? What's
Yes, sir.
cancellation? A minus B? You want me to cancel A minus B, A minus B?
Yes, sir.
Then we left with
A plus B equals B.
A plus B is equal to B. Very good. A plus B is equal to B. Right? And we took A is equal to B. A is equal to B. We can replace A by B. We can write B in the place of A. Okay?
Yes, sir.
Yeah. Do it. Replace A.
Sir, replace A by B.
Yeah. A plus B is equal to B.
Yes, sir.
As A is equal to B, as A is equal to B, we can replace A.
2B equals B.
Very good. 2B is equal to B. Frequently, my monitor stops, and the problem is very low till yesterday. From yesterday onwards, uh, monitor stops and starts every few seconds. It might be the mistake of monitor or CPU. I will get a new monitor today. Yeah, 2B is equal to B. Got it?
Yes.
Now, what can we do at this stage? We can divide.
B on both sides.
Very good. Yes. Now, what's the result?
2 equals 1.
Is it possible?
No, sir.
Why we got this?
I think the problem is in the calculation. I think it's A plus B by A minus B because A minus B is applicable to both of them.
Yeah.
So it will be A plus B by
That what's the flaw in it? What's the mistake in this? What's the mistake in getting this flaw? Yeah, there is an interesting book. I suggest you to read it. It is about the zero.
is it like A plus B by A minus B.
Yeah, A plus B by A minus B. A minus B cancels with A minus B. Yeah.
I mean that steps
Go ahead.
by A minus B. Is it that way? So it like this cancels. This one equals B.
Okay, there is only one A minus B in the denominator. Only one time A minus B.
Then where did
A plus B times A minus B is equal to B times A minus B. We know, as we noticed, A minus B is common factor in both sides. We decided to divide both sides by A minus B.
So what if we don't substitute it here?
Yeah, why can't we substitute? We can substitute, right? Yeah, there is a book. I suggest you to read it. Yeah. What I do read the letters reversely in.
No, sir, it's correct only.
Yeah, what it reads?
0, 0.
Yeah, 0. In this book, it's very interesting book. One interesting point is there at the end. In that point, yes. Can you see at my finger?
Yes, sir, but 2 equals 1.
Same result. Of course, he approached it in different way. He used the same idea. What is it setting?
Animal, vegetable, or minister.
Right. Yeah, he used the same concept. It's very famous, world famous. Charles C. Yeah, see. At last we got 2 is equal to 1, and we are thinking about where is the flaw in it in this result, right? But he continued and showed very abnormal results. 2 is equal to 1. Subtract 1 on both sides.
1 on both sides. 1 equals 0.
1 is equal to 1 minus 1. 1 is equal to. What happens when we subtract on both sides? What subtract 1 on both sides?
1 equals 0.
1 is equal to 0. Okay, he interpreted some controversial concepts also. For example, take one person. Let that name of that person be Subbarao. Okay.
Yes.
Yeah. Do you have any person knowing with the name Subbarao?
Yes, sir.
Okay. Let us take some person X. His name is X. He used the name of President of America to explain this concept. Yeah, let's take a person whose name is X, right?
Yes, sir.
X has one brain. It's very clear. X has one brain, right?
Yes, sir.
Yeah, applying this concept, 1 is equal to. Yeah, its result is 1 is equal to 0, right?
Yes.
Yeah, for example, a person is with name X has one brain. It is fact. That person, the person X has one brain, right? 1 is equal to
0.
0. 1 is equal to 0 means X has no brain.
Right.
Got the logic in it?
Yes, sir.
Instead of X, he used one famous person in that book. Deadly. Yeah, I am proving by mathematically that so and so person has no brain. Anyhow, it's not our area to discuss, but there will be many abnormal controversies, abnormal results by using this concept. For example, if I give you, I am sending 0 lakh rupees to you right now. Received? Have you received?
No,
Yeah,
sir.
I have phone paid 0 lakhs rupees to you just now.
Yes, sir.
How much money I have sent to you?
0. You didn't send me.
Have you received?
No, sir.
You might have received 0 lakhs rupees from me.
Oh, yes, sir.
Yes. Yes, this fact says 0 is equal to 1. That means in return, you have to give me
0 lakhs.
You have to give me 1. 0 is equal to what?
Oh, 1, sir.
1. As you have received 0 lakh rupees from me, you have to return how much to me?
1, sir.
1 lakh
1 lakh.
rupees. Okay. Have you got the logic in it? Have you understood the logic in it?
Yes, sir.
Yeah. In this way, he showed numerous unusual things. Okay. Anyhow, our interest is why it happens. To know why it happens. There is very interesting reason. As you said, the fly is there in this step only.
Yes,
There is
sir.
fly in this calculation.
Oh, what is it, sir?
What is it? As you told, a cancellation of payments be on both sides. This cancellation is not correct.
Oh.
Clearly, we can cancel. A minus B cancels with A minus B. But
Yes.
in this case, it is not correct. In this case, we should not cancel.
Yes, sir.
Because if A is equal to B, then what's the value of subtract B on both sides?
B on both
Subtract
sides.
B on both sides. What happens when we subtract B on both sides?
A minus B equals 0.
A minus B is equal to B minus B.
Yes.
A minus B is equal.
0.
That means it is 0. A minus B is 0. A minus B is 0. What did we do there? We cancelled 0 on both sides.
And made it.
See, when we cancel x by x is equal to 1, when we cancel x by x is equal to 1, here we cancel B on both sides, right? There is no mistake in it. There is no mistake in cancelling BB. See, when we cancel x by x is equal to 1, that means we mean that x by x is equal to 1. When we cancel x like this way, we mean its value is equal to 1.
Yes, sir.
Here, as we cancel A minus B by A minus B, when we cancel A minus B by A minus B,
yes,
it is equal to, we mean that A minus B by A minus B is equal to 1.
yes, sir.
That means we concluded that A 0 by 0 is equal to 1. Got it?
Yes, sir.
But 0 by 0 is not equal to 1. It is generated form.
Yes, sir.
We did not operate. We did not handle 0 by 0.
Yes, sir.
Unknowingly, we handled 0 by 0 and we wrote 1. That's why this absurd came. Got it? So the purpose of having this discussion is, don't take 0 by 0 as 1. 0 by 0 is not equal to 1. In the next class, we will discuss why 0 by 0 is not 1, is not something, not only 1, it's not something else. It is called indeterminate form. There are some indeterminate forms in mathematics. See, one more thing. Infinity minus infinity. What do you say about infinity minus infinity?
0.
No, it is also indeterminate form. We cannot find the value of infinity minus infinity. There will be a lot of controversies if we take infinity minus infinity is equal to 0.
So, but infinity is like, let's say it's a particular number.
Infinity is just an assumption for the value which is the greatest.
Sir, in that case, B minus B is equal to 0, no, sir. We can divide.
Yes. That's why we have known that the very important point. X minus x is equal to 0. This has also condition. X minus x is equal to 0 for x not equal to infinity.
Yes.
Yeah, and one more thing. 1 to the power of infinity also controversies. It is also called indeterminate form. Infinity minus infinity, 1 to the power of infinity, infinity to the power of infinity, among them 0 power 0 and 0 by 0. See, these are all indeterminate forms, right? And see one thing, I will show you one interesting thing. Yeah, all this is to get the insight of infinity, and that's the base for calculus. 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, so on infinity. Can I tell its value?
No, it's 0, sir.
Very good. How?
So it goes adding and subtracting the same number.
No need. Simply you can cancel all.
Yes, all the ones. And
all the values. You can cancel all the values. 1 minus 1 plus 1 minus 1 plus 1 minus 1. As you said, it is equal to 0. First term minus second term, result of first and second is 0. Okay. Third and fourth is 0. Fourth and fifth is 0. Fifth and sixth is 0. So 0 plus 0 plus 0. How many zeros? Infinity zeros. Okay. 0 plus
Yes.
0 plus 0 plus 0 plus 0 plus how many? What is its value?
Zeros.
0 only. There is no doubt in saying, but there is a controversial. At the age of in childhood, Srinivas Ramanujan questioned this and found this controversial concept. Yes, it is 0, right?
Yes.
But if you take like this, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 so on infinity. Yeah, we can understand the thought process of Srinivas Ramanujan in this example also. He raised a question. What happens when we take the cancellation like this? Leave the first term. Don't touch the first term, right? It is 1. Got it?
Yes, sir.
What's the result of second and third? Minus and plus 1 cancels. Its value is 0. Got it?
Yes. Yes, sir.
Next. Second, third. Fourth and fifth. Result is?
Zeros.
Next. 0. Next.
0.
0. Next.
0.
0.
0.
So on zeros. Its value?
Ones.
So, in one method we got 0, in another method we got 1 for the same question.
So it's based on the it's based on the question, no, sir. Like if we wanted to leave
Okay.
1, then
Same question, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 so on infinity up to infinity, infinite series.
but it's like we held the 1 behind. If not, we just get the answers, you know.
Please tell, is it correct to take like this or not? For example, 1 plus 2 plus 3. Okay, you do this addition like this. 1 plus 2,
3.
3 plus 3,
6.
I do like this. 1 plus 2 plus 3. I left 1. What is 2 plus 3?
5.
1 plus 5?
6.
Can we do like this or not? It is this process is accepted or not accepted?
It is accepted. So, but when they're like different signs, that's where there's like BODMAS rules and all that, no, sir?
BODMAS rule is used for different operations, plus minus into something like that.
Yes, so we have plus and minus here in the question, no, sir. There's only addition in the question.
Yeah. Even if you use that concept, yeah. We should take plus first, as you said, right?
Yes, sir.
Even for it, we get the same. Suppose question is like this: 1 minus of. Yeah. For our clear and for our question, I am writing like the same series like this. The question is 1 minus 1 plus 1 minus 1 plus 1 minus 1 so on infinity, right?
Yes, sir.
Yeah. See, 1. Take minus common from the remaining all terms.
1 minus 1.
Minus 1 plus 1 minus 1 plus 1 minus 1 plus so on infinity. Agree?
Yes, sir.
As you do in the above calculation, we got 0 for this bracket value. Accepted?
Yes, sir.
So it is 1 minus of 0 is equal to 1.
Oh.
Even if we use BODMAS, we got 1 only. Okay.
Oh.
That is very, very, very controversial and very interesting about infinity. One of them is this. Yeah, let's come to our topic. So it's very clear that we should not cancel 0 by 0, right?
Yes,
Right. Yeah, students are taught to find the value of limit extends to 2 like this. The question is, we will discuss more things about infinity in the next class. Limit extends to 2. X square minus 4 by x minus 2. Students are taught to solve the problem like this. There must be a question. There must be a question while doing this process. Limit extends to 2. What is x square minus 4? X tends to 2 means, what is your opinion about x tends to 2? What do you mean by x tends to 2? X is equal to or x approach to?
X reaches 2 but never is 2.
X tends to 2.
Yeah.
That means very clearly x is not exactly equal to 2.
Yes, sir.
X is not equal to x tends to 2 means x tends to 2 means x is not equal to x is not equal to.
Yes.
Got it? Clearly x is not equal to. Yeah, note that, underline that point. X tends to 2 means x is not equal to, but the value of x is nearby to.
Yes.
See, use a square minus b square formula.
X minus 2.
A minus b into a plus b.
Yes. By x minus
By x minus 2.
x minus 2, x minus 2 gets cancelled.
Very good.
That equals x plus 2.
Now plug in x is equal to
2 plus 2, 4, sir.
That's why Desmas shows f of x is 4x is for x is equal to. Got
Yes.
it, Ethan? And here
Yes.
the solution is also completed. Limit x tends to 2, x square minus 4 by x minus 2 is equal. Finally, its answer is 4 only, right?
Yes.
There is no mistake in it. But
Yes.
there is a question. In the previous example, we faced an absurd by doing the same cancellation. By cancelling a minus b on both sides, we faced an absurd.
Yes, sir.
This cancellation led to an absurd. Okay. So that means we should not cancel 0, 0, right?
Yes.
The lesson from that from that absurd is 0 by 0 cannot be 1. That means we
Yes.
cannot 0, 0, 0 by 0, right?
Yes.
But what did we do here? We cancelled x minus 2 and x minus 2. Got it?
Yes.
There we faced an absurd. Then is it correct to do this cancellation like this? As x tends to 2.
I mean, because we know that one of the value is a number, sir, maybe.
Yeah.
And there's only one variable.
Think clearly. When x is equal to, see, when x is equal to, what is x minus 2?
0, sir.
0. That means it is 0. Here this x minus 2 is 0, right?
Yes, sir.
This x minus 2 is 0.
Yes, sir.
Is it correct to cancel these two values now? Answer now.
No, sir.
Yeah, then why this solution is correct? But the solution is correct. There is no mistake in this answer and in this steps. There we find it wrong. Then we find it wrong. We in the previous cancellation, canceling such terms is wrong.
Yes, sir.
But here it is correct. Can you know the reason? Can you identify the reason why it is correct to cancel x minus 2 on both x minus 2 in numerator and x minus 2 in denominator? It is correct only. We can do it.
Yes, not sure,
It's
sir.
wrong here. Why it is correct here?
I don't know, sir. Maybe there's like two
Yeah,
variables in it.
see, right top. Concept of right top.
No, sir. Right top.
Yeah, right top. There is a point in right top on the screen.
Right top. Oh, x tends to 2, but x is not equal to 2.
Yeah, x tends to 2 means
X approaches 2, but never is 2.
yeah, that means x is equal to or x not equal to.
X is not equal to 2.
That means we cannot think like this. X is equal to not x is equal to
Oh.
approaches 2.
Yes, sir. Yeah.
Then x minus 2 is not equal to 0.
Yes.
X minus 2 not equal to 0. But x minus 2 is the value nearby 0. 0.0000 like that. So the values of x are not exactly 2. The values of x are maybe 2.1. If x is equal to 2.1, then x minus 2 is
2.1.
0.1. So if x is equal to 2.01,
Yes.
then x minus 2, x is equal to 2.01, then x minus 2,
2.01 is 0.1. 0.01.
0.01. So here we are not cancelling 0 by 0. As x tends to 2, we are cancelling 0.1 by 0.1. Or 0.01 by 0.01. We don't cancel. We shouldn't cancel 0, 0.
Yes.
But we are allowed to cancel 0.1 by 0.1. We are allowed to cancel 0.01 by 0.01.
Yes.
We can cancel 0.001 by 0.001. This cancellation is right. Got the reason? Got the logic here?
Yes.
Yeah. For example, in the case, it is correct. It is correct. There is no mistake in it. But if the question is like this, if f of x is equal to x square minus 4 by x minus 2, then find f of 2. If it is the question, our solution is like this. Given f of x is equal to x square minus 4 by x minus 2, right?
Yes.
Then f of 2 is equal 2 square minus 4 by 2 minus 2. 0 by 0. Hence, this problem has no solution. Got the difference? Answer for the second question is no solution.
Yes.
Answer for the second question is no solution. Answer for the first question is 4.
Yes.
It clearly says the difference between function value and the limit value.
Yes.
Hope you have got the basic concept of limit, right?
Yes, sir.
Right. Now, yeah, if we are asked to find the value of f of 2, we conclude this problem has no solution.
Yes, sir.
But if we are asked to find the limit value, we give the solution or the answer as 4. Got it?
Yes.
Practice. Let us do some questions regarding this. I'll show you. Try second sum. What happens if you plug in 2?
Tends to 28 minus 22 minus 6.
What happens?
8 minus 22 minus 6. 0. 12 minus 2 minus 10. So it's 0 by 0. Sir.
But there is no 0 by 0 in 4 options. In 4 options.
Yes, sir. Maybe we factorize and then we can cancel it out.
Yes, you are right. Very good. Factorize numerator.
1 second. So it will be 10, 30, so 3x square minus 6x plus 5x minus 10 x minus 2 x minus 2 minus 2 3x plus 5 factorizing 7 for 7 times 6 42 42 7x square minus 14x plus 3x minus 6 7x comma x minus 2. Six plus 5. Okay, 7 times 14. 17 by 6 plus 5, 11, 17 by. So is it option 4?
Very good. Yeah, what is the numerator? X minus 2 times
Sir, sorry. The answer is option 1.
option 1, right? What is the numerator? Factorization of numerator?
Numerator x minus 2 times 3x plus 5
Whole
by x minus 2 times 7x plus 3. 1 second. So the numerator is 7x plus 3 and the denominator is 3x plus 5. Plus 3 and denominator is 3x plus 5.
3x plus 4.
5.
X minus 2 cancel. We can cancel.
Yes.
Without hesitation, we can cancel x minus 2 here. That means we are not cancelling 0 by 0. We are cancelling something like 0 by 1, 0.1 by 0.1, 0.001 by 0.00 like that. Okay?
Yes.
It is accepted and it is allowed to do this cancellation. Yeah.
Yes.
Limit extends to 2. 7x plus 3 by 3x plus 5. Replace x, plug into 14 plus 3 by
14 plus 3 by
plus 5.
plus 5.
17 by 11. Very good.
17 by
Very good. You did it correctly. How to do sixth question? What happens when we plug in -1? It extends to -1. What
1, 3, 4, 4 minus 2. 4 root is 2, 2 minus 2 is 0, sir. That's what it is.
numerator?
Numerator will be 0, sir. 0 by 0.
0 by 0. That's why we don't plug in -1 at this stage.
Yes, sir.
So in the previous question, you factorize it, right? Here there is no scope for factorization. There is no scope for factorization. Then what should we do? That is called rationalization. Do you know about rationalization? Have you ever come across the concept of rationalizing?
You told me multiplying the numerator to.
Yeah, the middle sign is negative. Multiply its opposite sign. That is root of x squared plus 3 plus 2. Multiplying numerator and denominator by its rationalizing factor. X squared plus 3 plus 2. Got it? Then the numerator is limit extends to -1. X plus 1 times root of x squared plus 3 plus 2 whole by. Yeah, use a minus b into a plus b concept. A minus b into a plus b.
Root x squared plus 3 whole square.
Very good. Root of x squared plus 3 whole square.
Minus 4.
Minus 4. Very good. Yeah, don't change the numerator. X plus 1 times plus 2. Denominator is here root square cancels, right?
Yes.
X square, you know what is the value of root 5 square?
5, sir.
5, because root 25 is equal to 5.
Yes.
That's why root of x square plus 3 whole square is x square plus 3 only.
Yes.
X square plus 3 minus 4. Limit extends to -1. X plus 1 times root of x square plus 3 plus 2 whole by denominator is x square plus 3 minus 4. What's the value of 3 minus 4? 3 minus 4.
1. Sorry, negative 1.
1. X square minus 1. X square minus 1 can be written as x square minus 1 square.
Yes.
It extends to -1. X plus 1 times
X minus.
of x square plus 3 plus 2 whole by use a square minus b square formula here. Square minus
X,
b.
X minus 1 times X plus 1.
Very good. What happens now?
X plus 1 and X plus 1 gets cancelled.
Very good. Now we can put
Negative 1
that means square root of -1 whole square is positive 1 only.
plus 3 plus 2 by negative 2.
Yeah, go ahead. -1, -1.
Root 4 plus 2 by
What is 2?
negative 2. 4, 2 plus 2, 4. 4 by negative 2. Negative 2, sir. Is negative 2 answer?
Option
1, sir.
try second sum as homework. Second question.
Yes, sir.
X of that question. Right? Got it?
Yes, sir.
Now apart and fifth question also. It's somewhat challenging. Fifth question is also challenging. Try.
Yes, sir. I'll try, sir.
Apart from those, I am giving some questions. Limit extends to 2. Limit extends to 3. X cube minus 27 by x minus 3. Limit extends to 2. X square minus 5x plus 6 by x square minus 9x plus 40. Limit extends to 4. X cube minus 64 by x square minus 7x plus 12. Try these 5 sums as homework. We will be learning very interesting questions in the next class. Okay?
Yes. Yes.
Thank you, Tanya.